Ciao friends! In this video we will see how to create an account receivable aging report in Power BI. The challenge is not how to write the DAX code, because you know what? The DAX code is ready to use. Not only because we have the code ready in the file that you can download, but also because I reused existing DAX patterns. So the challenge here is to understand how to define a proper data model for a business problem and then transform the data with the simplest possible transformation that you can use so that you save your time to do the minimal amount of effort and then reuse existing solutions that are ready to use. Let's start with the demo. So let's start looking at the final report we want to obtain. We aim to this chart. Of course, we could get a matrix, but the chart is nicer to see. And every month we have the total amount of account receivable which are payment past due date. So we expected a payment, for example, by the end of January, but for some reason the payment is not completed at the end of February. So we are past due date, and that is an amount that is represented in this report. And the amounts are divided by the age. So we have a different color for a range of ages that we want to include in the report. So there are several challenges here. And the first one is we want to understand what is the starting data source, what is the format of the data we have in the data source, and then how we create the proper measures and report to achieve this goal. Now, this is a very, very common business problem. But the reality is that if we just get the data that we have at the beginning and we try to solve the problem without modifying anything in the data model, we end up creating every time a different measure, a different report, but basically to solve always the same problem. So why not taking a different approach about these kind of problems? If I have a classic problem, account receivable aging, I could start saying, okay, this is the standard report and the standard model that I want to use. And instead of trying to adapt my code or my report or creating a new version of my code and my report for the specific data source that we have, we just try to extract from the data source the data that we need so that we solve a small problem, which is transforming the data into a format we expect to have, and then starting from that, we obtain the report. So the idea is that instead of starting from which data we have, how do we compute the right number that we want to display, we will see the problem from a different point of view. Yes, we will see how the data is structured in the data source, but my point is that in a different environment, this model could be different. And this specific problem has a number of nuances that we have to understand, because it's not a problem that we can solve without writing a single line of DAX code. But we want to try to keep the DAX code at the minimum. And that's the goal for which we need a specific model. But let's start looking at how we have to manipulate the data to obtain this report. So let's take a look at how we might have the data in our data source. And we try to see the problem in, let's say, one of the worst possible conditions, which is we might have a list of invoices that we issue to the customers. But each invoice could have different payment terms, which means that for each invoice, we might have more than one due date with a different amount, which is exactly what we see in the payments due table. So the payments due table has, for each customer in each invoice, a date and an amount. For example, we see that for the invoice number 2, for this customer, we have actually 2 expected payments, one mid-November and one mid-December. So the total amount of 16,000 is divided in 2 payments, 8,000 each one. Now, in an ideal world, we just have for each invoice, one due date and one payment, usually within the due date. In the real world, something strange could happen. For example, we might have payments that do not match exactly the amount of the due date and the payment due at the due date. For example, we have, in this case, if we consider Litware, the first invoice of Litware, this invoice number 1, was an invoice of 10,000. The amount due was 10,000 and the due date was mid-October, but the payment that this customer made at the end of October is 7,000. So you see that we have, let's use a different color for this, we have an amount due of 7,000 but a payment of 7,000, which means that from the next payment, 3,000 is must be associated to the invoice 001 and the remaining part for the first due date for the invoice 002 and so on. And you can notice here that, so we have a certain amount of this 13,000, sorry, no, don't use this one, a certain amount of, let's use this one, a certain amount of this 15,000 should cover part of the payment of 10,000 here, but the other amount of 15,000 is the entire amount here, so is 3,000, 8,000, 11,000, so probably there is also other 4,000 here. So you see that a single payment that we have, 15,000, covers 3 different expected payments. And this is just an example of what could happen in the real world. Now, thinking about, okay, I keep the data as is, and I try to implement the calculation in DAX, it's a total nightmare, because trying to reconcile the payments with the due date or the invoices, it's a total nightmare. You don't want to do that for every query. So we probably want to do something in order to prepare the data to make it simpler to execute the report. And so where I want to go, I want to obtain something like this, something where we have a single table where we have one row for each intersection of the cardinalities between payment due and amount paid. So basically, we want to create all the possible combinations so that every row is the intersection of an expected payment and a payment that had happened. But in case, for example, we had 3 due dates and only 1 payment, we need 3 rows. But we could also have a case where we had two rows payment due for 2 different dates, so 2 rows in the payment due, and then we have other 2 payments, but with different dates, with different amounts, and we end up having, for example, 3 rows in the intersection of those. In this example, we can see that the invoice number 1, that if you remember, had only 1 due date, and the entire amount was expected here. The entire amount was expected 10,000 at the in mid-October, but we noticed that we had 2 different payments, and the second payment actually covered also the part of the invoice number 2, and so this is represented in this table. So basically, this is the intersection of the payments, so that we have the amount paid is split across the different due dates that we had at the beginning. Now, this table is what makes my DAX code easier to manage, because at that point, when I have to evaluate the amount that I want to report, that I want to include in my report for a particular month, it's easier to do a single scan of this table and to filter those transactions that I want to include. Let me clarify with an example. If you remember, we have seen that in the report, let's take a look at the report. The report has for each month, let's see here, for each month, which means for each end of the month, we have 1 date, and at that date we want to get a sort of snapshot of those payments that were not completed within the due date. Now, what we have to do, if we take a look at the algorithm that we will implement, for each transaction in the table we have seen before, we have actually 3 dates: the invoice date, the due date, and the payment date. But to be honest, the only thing that we are interested to are these 2 dates, the due date and the payment date. Whenever the payment date is past the due date, then we have a meaningful information for our report. And the age of that amount, the account receivable age, is the number of days between the due date and the reporting date. So if we are at the end of February and we have an invoice that, let's let's say, has a due date at the end of January, we have 28 days of age, or 29, depending on the number of days in February. So this is what we have to implement, and that's the reason why this structure is something that makes my life easier. So I want to start writing the DAX code from this structure, but let's take a look at what we had at the beginning. If I had this structure, or a different one, because this is just one of the many cases that we could have, if I have to start from this structure and complete the table, the structure of the table where I have a single fact table with this granularity, this could be complex. And actually creating this table is not actually easy. So instead of trying to immediately solve a complex problem, a complex data transformation problem, we aim to an approach that has at least two steps. The first step is that whatever data source I have, I want to obtain, let's say, a well-known structure for my data. Let's take a look at what we have here. So what is this well-known structure? Well, what we want to do at the beginning, we want to obtain a table that has a list of movements, where let's say every date is a single row in this table. Every date, that could be the invoice date, the due date, or the payment date. And so if I create this table, and I can show you the content of this table, the table is called movements, I want to obtain something like this. So if I sort by document, just to show you an example, we have in this case this is a simple example for many of these invoices, where I have a single invoice, this one, 28th of February, a single payment due event. So for this date, April 28, I have the same amount, and the same amount has been paid, in this case later, after the due date. Sometimes it could be before, and so on. Now, you realize that this structure doesn't force me to have only one payment for each invoice, one payment for each payment due. So I could have any kind of mix of those. What I have to do at this stage, though, is to allocate payment to one invoice, not to a single due date, but to one invoice. So if I have like in the case I described before, a payment that can include multiple invoices, that's an additional step. So first step, split the payment into the invoices, and then allocate the payment into the due dates for that payment. That's the second step is what we do here now, but just allocating the payment into the different invoices is something that we don't do at this stage. In this example, I assume that I already solved this problem. So if you imagine how do you populate this table, you can see that in the example that we provide with the article that you can download, we basically retrieved date and amount from different tables, and we combine these tables together. Now, this is a calculated table in DAX. This is good if you have less than 1 million rows. But if you have a large amount of data, you don't want to do this transformation in DAX. You want to use SQL, you want to use a Power Query, you want to use some other tool, Python or a notebook. You have Spark, you have so many options available. But I would use SQL, for example, but that's a detail. So the important point is that if I can obtain this structure, now I know that I have let's say, a model that is relatively easy to populate, regardless of the data source that I have. And now from this model, I can do the second step in a transformation that in this case I show you in DAX, which is what we created here. This AR detail is a table that has for each document, okay, for each document, for example, let's sort by invoice number. For each document, we have the invoice date, the due date, and the payment date. But remember, for one document, we might have multiple rows. Now, how can I test it? Because if you open this model, you will find that the tables that we generated are generated automatically, so we don't have complex cases here. But the structure I created, the movements table, can actually have multiple due dates for one invoice, multiple payments for one invoice, and so on. So in order to test that, my suggestion is don't start with the actual data that you have. Create a subset of fictitious data that you can use to test the extreme situation, those boundary situations where you want to make sure that if you can handle the borderline cases, you will handle well all the common cases. And so that's the reason why I have a different version here that I'm going to show you now, which is called sample. And here in the movements table, I populated the movements table with a small list of transactions that are very, very close to the one that you have seen in the example before. Actually, I created also an invoice 4 here, but the invoice 1, 2, and 3, these are exactly the same invoices that you have seen on the whiteboard before, and you will see also described in the article. Now, this make it easy. The data set is very small. So if I look at the report now, you will see that I have a very small amount of data. And what I want to do, I want to create some analysis like this one. But at this point, it's easy to understand with this report whether I am allocating correctly the invoice amount to the right date, the payment due to the right date, to the right due date, and the amount paid to the right payment date. So you see that here we can actually see the detail by date and invoice that actually represent what I had before. Now, the data that you see here, the data that you see in this chart is what? Well, this is exactly the data from the movements table. The movements table is like a fact table connected to several tables that we have seen before. We have the customer, we have the date, and we have the movement type. The movement type is just a description that says invoice, payment due, and payment, an actual payment. So this is exactly what allowed me to create this report. And basically, the population of movements, that is my starting point for the analysis, is what allows me to see this report at the end. Okay. So now, if I have this report here, what can I do? Well, now I can create the table AR detail that I actually need to do the analysis in DAX, to create the report in DAX. And we said, well, we needed to create a single line where a single line corresponds to the intersection of payment, amount paid, payment due, and the invoice, of course. Now, the invoice is not a big deal, but actually in this case, why do we have two rows for the invoice 001? Because we had the amount that has been paid into tranches. And so this amount due, you see that the date amount due is 10/15, and the amount due is actually split with the same amount that has been paid. Why this? Well, because when you group the data by due date, the total is 10,000, which is actually the original payment due at the due date 10/15. Now, the idea of allocating the data this way is because we want to just aggregate the data. And why do we have two columns, amount due and amount paid? Well, because sometimes there could be an amount that has not been paid. And so that's exactly what allows me to get the aggregation the right way, but also to quickly locate those payment that has not been completed yet. And so in case we do a report after December 15, this is already an account receivable in an aging state. So we want to see the trend over time of the past invoices that have been paid, but at that point in time were not paid yet. But we can also see the current situation, of course. So so in this case, these invoices, the part of these two, the 2000 part of these two invoices has not been paid yet. And so whatever date in the future we look at, this is a credit that is aging. And you see this in the chart. The 4,000 that you have seen, this is the open amount we have all the time. So how do we create this table? Well, once again, transforming the table movements into this table is something that we can do in many ways. You will find the solution in DAX here, and I'm not gonna spend half an hour describing the entire transformation here, but if you want to take a look, this is an interesting technique that you can use in DAX to transform data in a model. If you have less than 1-2 million rows in the movements table, probably the performance is good enough. If you start having tens of millions of rows, my suggestion is to look elsewhere, because the calculate table is recomputed every time for the entire history, and it doesn't make sense, because what happened in the past is not going to change. So once the payment had been completed, we could just reuse what we already computed. So you can implement an incremental refresh if you prepare a transformation outside of Power BI, whereas if you do the calculation in a calculate table, you always compute the entire history every time you refresh the model, which is not ideal, in my opinion. Now, the goal here is to understand that instead of using this, let's say, common data source that we want to have, so you have any different data source, you put the data in this model, then at this point we can just apply the pattern that I am showing you, and I will show you in a moment the description of the generic pattern that we are using, which is the events in progress. But one second. Once we have the AR detail table, we have another fact table, another table that contains events that is connected to date and customer. In this case, we don't have the let's say the transaction type that we have seen before, because every row has 3 dates. And actually, what we want to do when we have a reporting date, if you remember, we have seen before, when we have a reporting date, what we want to do, we want to extract all those rows where my reporting date is between the due date and the payment date, or is past the due date if the payment date is blank. So that's what we do in DAX in our measure. So our measure, using this table AR detail, is doing exactly this. So if we take a look at how this open amount calculation is working, we can see that the open amount calculation is the DAX code that implements a pattern that is the events in progress pattern. So I'm not going to explain this measure in detail, because this is exactly what we have already in this DAX pattern. So events in progress is the pattern that we are applying. Whenever we have dates, start date, end date, in this case, due date, payment date, and we want to track which events are, let's say, open, active at a certain point in time. In this case, we want to collect, we want to aggregate all those payments that are past due date but before payment date for the reporting date. Well, that is exactly what this pattern is doing. And in this article, you will see how to implement also different analysis, where instead of considering only one date, you consider a period. So there are a number of considerations made here. What we're using here is the end of period calculation, because if we select a month, we want to go at the end of the month and analyze what we had open at that time, and we just applied the pattern. So what the DAX measure that you see is a, let's say, is a customized, not customized, is a, let's say, is a translation in our model of the generic pattern that we have here. And this pattern is already optimized if you don't have too much data. What does it mean? If you don't have more than a few million rows, I would say, and probably also something less, probably. Why this? Because for every point that you have in the report, you end up having a calculation that scans the entire table. Now, we're looking at the data month by month, but if you start creating an analysis day by day or week by week, you increase the number of data points and you slow down the performances for the query refresh. So not the, yes, for the refresh of the report. Just to view the data, if you change any parameter, it would be slow. And what happens if that is slow? So the volume version of this, so the model that I populated with the larger number of rows, is actually slower. If I try to run here in Optimize, Performance Analyzer, start recording, if I refresh the visual here, you see that this visualization is requiring more than 1 second to complete the chart. You might say, Marco, this is good enough, it's fine. Okay, but actually, my expectation is it should be much faster. And I can go faster when I have a large amount of data. What I want to do, I want to avoid computing this every time. I can pre-calculate something, especially if I know that my granularity is by month. We can create snapshots. So basically, we can pre-calculate the data at least for the end of the month, for example. And this is what we did for by using this AR detail snapshot. And this optimization is also described in the DAX pattern that I mentioned before, in the events in progress pattern. So you will see in that pattern also the implementation of the snapshot. But remember, we are not just combining the snapshot. Here we are combining two patterns, the events in progress pattern, and because in our report we want to analyze the age by group, what happens? Every invoice has an age in number of days. One invoice, one payment is 25 days past due date, another one is 28, another one is 15. But all these three transactions are within the 0-30 days. And now, how do I compute this? Well, we have to do several steps, but once again, we have another pattern that describes what we call the dynamic segmentation. Dynamic segmentation means that at query time, depending on the filter, we group the result of a measure into a certain range. And the result of a measure is the result of the difference between those two dates. Now, in the snapshot, we can pre-calculate this for each snapshot. But in the initial measure, this was computed at query time. So the difference is that when we use the AR detail table, the table aging range, the table that describes my ranges, which is something that you can customize. So if I go in this table, I can customize this table, and instead of having these ranges, I could create my own different ranges. This table is evaluated dynamically at query time because every invoice could appear in different months, right? If an invoice, if a payment due had a payment 4 months later, for 3 or 4 months, you will evaluate the same row multiple times. So with the snapshot, the difference is that we pre-calculate all the values for each month, which means that the snapshot creates multiple rows. So this table, AR detail snapshot, is basically the same table that we have seen before, plus the snapshot data that tells me what is the report date that we want to use, and the segment, the group of age, the age range that we want to allocate. Because this way, we have a direct relationship with the aging range, which is the table that in the other version is disconnected. So once we have the AR detail snapshot table that is much larger than the AR detail that we have seen before, we can connect aging range, and guess what? The measure that we write in DAX for the snapshot is so simple. It's basically just a sum, sorry, not this one. This is amount of data. This is the amount of data is the measure that we use in the AR detail model. The value for the snapshot, sorry, is this one, open amount snapshot, is just a calculate with the last date. This is-cross filter is there just to make sure that we do the calculation when there is a date selected, otherwise we don't show a result. So that's the complete navigation about how to solve this problem. Of course, remember, my goal was to explain the approach, the way we split the problem into smaller problems. Some of them already have a solution ready, so we can spend our precious time only solving the missing part to connect all the dots and having the report ready. So we have seen that we have a solution that we can already use. We have seen how to move any data source to a common structure, the movements table, where we have a list of business events. In our case, 3 events. Invoice issued, payment due, and paid amount paid. then we have seen that starting from this very simple star schema, we transform the data into another star schema where the cardinality of the fact table is different. The cardinality is no longer a single date. The cardinality is the intersection of different dates, so that it is possible to aggregate our amounts by any date without any problem, but it's also possible to find those transactions that are where the payment date is past due date, which is the event that we are interested to in our report. At that point, we have also seen that we can optimize the solution by using a snapshot. It's not required in every situation, but if you have millions of rows, millions of transactions to analyze, if you want a report that returns your information in just a few milliseconds, then you can implement the snapshot too. And we have seen how to do that in Power BI. As usual, enjoy DAX!